And as a reminder, for more Microsoft Webcasts, you can visit Microsoft.com/webcast. And again, I'd like to welcome everyone to today's Msdn webcast, ASP.NET Ajax Client Libraries, Object-Oriented Development. It's my pleasure to introduce today's presenter. We have Rob Begbie joining us today. Rob is a Msdn developer evangelist with Microsoft Corporation. Now, without any further delay, I'm going to turn the floor over to Rob.
Okay, thanks a lot, Tracy. I really appreciate that. Again, my name is Rob Begbie. I'm a developer evangelist for Microsoft Corporation. On this slide, you'll find my email address and blog site. I'll have all the sample codes we're running today out on my blog probably an hour after the presentation. If you have any questions afterwards and you don't have the opportunity to enter them into the question manager, don't hesitate to send me an email at rob.begbie@microsoft.com. Without any further ado, we're going to jump into this because we have a lot to cover. What we're going to be doing to kind of level set what we're going to be doing is talking about the OO concepts that the ASP.NET Ajax client libraries have built into JavaScript. And so in order to help illustrate or illuminate, if you will, demystify what's going on, we're going to be talking about how things work in JavaScript outside of the Ajax client libraries, and then we'll talk about how things work within the Ajax client library. So this should be an interesting session. If you've wondered how these technologies work, we should be answering many of your questions today. So here's our agenda. We're going to be talking about our namespaces implementation, which is relatively simple. Then we're going to go into classes, how classes work, how we kind of have that template type methodology in JavaScript, how that works, and then how we've created this classes implementation in ASP.NET Ajax. We'll do a brief demo on enums and show you how those work. Then we'll get into inheritance and how inheritance works in JavaScript, and then how it works inside of ASP.NET Ajax, because we're using a differing methodology than you see in JavaScript. And lastly, we'll talk about interfaces and our interface implementation, how that works, how you can create them. So without further ado, what I want to do is jump into a quick demo to kind of set the context for what we're doing throughout this series. If you're not familiar, we've got about a 10-plus part series on the client libraries, and what we've been doing is trying to illustrate how you may create an application that looks similar to this using the client-side libraries. And so as this app comes up, we're using pretty much all client-side JavaScript libraries to provide functionality. This simulates an Amazon-type system where you can page through varying catalog sets and add differing items into your basket and remove them all without doing full-page postbacks. This isn't using update panels or anything like that. It's using all client-side, all of the client-side libraries that we have, making the asynchronous calls over HTTP using XML HTTP under the covers. There are previous webcasts on making these service calls, so you can take a look at those. Today we're going to be talking about some of the OO concepts. So looking behind the scenes in our catalog.aspx, when we're getting the results back from our web service call, you'll see this code is our callback code. And what we're doing is actually getting a reference back into our catalog component, which is a class of type control. And then we're just simply setting some properties on it and then calling some methods on it. And so earlier in the code on init, I actually create an instance of this component, this catalog component. We'll be demystifying these use of controls later, but today what I want to do is show you kind of at a higher level what are the OO functionalities that we have that allow us to then create this deeper implementation. So with that, let's jump back into the slides. Don't worry, there's going to be plenty of demos today. And let's jump into namespaces. The first question is, why do I care about namespaces? A lot of people really don't understand the importance of namespaces, and it's often difficult without a demo to show why it's important. Firstly, it's nice to organize your code so people can easily understand where your code exists. But what's truly important is that we can prevent collisions, and that becomes very important when we don't have control over all of the classes people are going to be using. So, for instance, I may have my version or implementation of an employee class where somebody else may have their own implementation. If I bring both of these in and I don't have namespaces to segment these, then I will have a collision between those two objects. That's probably your typical or canonical example you get. In reality, when we start using varying Ajax libraries, like maybe we're using some of the Scriptaculous libraries and maybe the ASP.NET Ajax libraries, and we start bringing in a couple, two or more sets of these libraries, the odds are going to get pretty high that the object names or the class names may be the same. There's only a few ways to name a rich text box, for instance. So the fact that we built these namespaces out is very nice in that now we're not going to collide with any of the other libraries. So this really talks to the interop story. So that kind of gives you the reasoning why. If you look at the bottom of this slide, you'll see an example. It's relatively simple. You just call type.register namespace and you give it the full registered namespace. Then from there on out, when you're referring to your class, you just use the fully qualified name. So the namespace plus whatever your class name is. It's relatively simple. So what's actually happening? How does this work behind the scenes? When I go to call type.register namespace, what we're really doing is creating a hierarchy of objects. And so it starts at the window object. So if you'll look here on this slide, if I call register namespace shopping.controls, what really occurs is window now has a shopping object associated with it, which has a child controls object associated with it. What you're probably more used to, window.shopping.controls is now an object. And so then when we create our class that's tied to that, its parent object is controls. So the pseudocode, if you actually take a look at Microsoft Ajax.debug.js on line 850, you'll see this code in its entirety, but the pseudocode essentially is listed here. We essentially set a root object to the default window object. We take that namespace string that you passed us, we split it by the period or dot. We iterate over each item in that resulting split array. And so we add an object to root object if it doesn't exist each time, and then we set a couple props. The type name is set to on the new object to whatever that namespace is, and namespace is set on the new object to true. We also add a getName function to that object, and then the root object is set to this new object. So you can look at this code yourself. It's pretty simple. Essentially, all we do is iterate through each of the items that are split from that period and add them into that object array starting at window. So it's pretty simple implementation, but also pretty powerful. So let's jump into our first demo on namespaces and kind of show off the importance of namespaces. So let me close this file out, and we'll open up a couple of bits of code for us. So the first thing I want to do is take a look at our demo code. And you'll see at the very top inside of the script manager, we're importing some scripts. And so in this case, I've imported, let me just go to full screen here. And so you'll see that I've imported a script called no namespace Contoso employees. I've not imported no namespace Fabricam employee yet, and I've imported namespaces .js. So these are the two you really want to worry about, Contoso employee and Fabricam employee. Let's take a quick look at those. So here's my Contoso employee. I created an object called emp. We'll talk about JavaScript prototypes in just a minute, but for now, just notice that we're creating this function called emp, and it has an implementation. Inside of here, I have an instance field called SSN, and inside of here, I've got a getter and a setter, and a toString method that returns Contoso employee, and then appends the social security number. My Fabricam implementation uses the same named object, if you will, emp, But instead of just passing the Social Security number, we pass a couple additional fields and set a couple instance fields here as well. We add in a couple additional getters and setters, and then we have our own implementation of toString, which as opposed to Contoso employee, we've got Fabricam employee, and we append the additional information. So you can see it's two differing implementations. Let's go over to our calling code and take a look, and let's call some of these. Note that I'm not bringing in the no namespace Fabricam yet, the latest one that I showed you. So all we should have is really our Contoso implementation. So if I go into my first bit of code that I'm going to call, you'll see I'm creating this employee Contoso, passing in the constructor for my employee, my Contoso employee, and then calling toString. Secondly, I'm going to call I'm going to create, hopefully, my Fabricam implementation, passing in all of the information that that Fabricam constructor wants, and I'm going to call alert. Now, knowing that I didn't bring in that JavaScript file, this should fail. Let's go ahead and take a look at it and see what happens. So, go back out, and let's spin this guy up. So when I create my Contoso employee object, it works as expected. Now what happens when I call to create this? We're expecting it to fail, but essentially my Contoso employee object took over, and so that it did actually work for that implementation. That's kind of a problem, but maybe not as bad as we're going to see just here in just a moment when I uncomment out this line here to bring in my Fabricam employee implementation. So let me just go back and uncomment this. So now what I did there is I just brought in both my Contoso and my Fabricam employee implementation. So just quickly again, my Fabricam has the additional implementation where I've got a toString which returns a Fabricam.employee or Fabricam employee in the additional information, and my Contoso essentially has the implementation which passes back Contoso employee. Well, let's see what happens when we run that. So let's run it again with both of these implementations brought in. Well, you'll see I just clicked on my Contoso, and now my Fabricam employee object clobbered my Contoso implementation. My Fabricam works fine now, but the Contoso doesn't work. So I've got this collision between these two objects because they're named the same. We didn't have nothing was there to protect us saying you have two versions of this and you don't know which version you're getting. The challenge was you got whichever one was registered last in this case. And so you can see very clearly in this implementation that there's a problem with collisions if you have objects in JavaScript of the same name. So how do we solve this? If we take a look at the ASP.NET Ajax implementation, you'll see what we do in this case is, first thing we do is we call type.register namespace Contoso components. We then use that fully qualified path to create our employee object. So contoso.components.emp equals function. Inside of here we call initialize base. We'll talk about the importance of this later. And then same implementation, this .social security number. And then inside of our prototype, it's the same implementation. And then we just call register the class with our fully qualified path. The same thing occurs for our Fabricam. We call type.register namespace a different namespace for Fabricam. Again, fully qualified path for our constructor. Same implementation. Then we've got our prototype, which has the exact same implementation as before, return Fabricam employee, and then we call register class, passing the fully qualified path to that class. Okay, let's see what happens when let's take a look at the calling code for that so you can see what we're doing. And let me jump back down to that code. And so you'll see down here, this is where we're creating our employee Contoso equals new contoso.components.emp versus our Fabricam, which is fabricam.data.emp. And in the Fabricam case, we're passing the additional data. And in both cases, we're calling toString. Let's see how that works. In the Contoso, we're getting the appropriate Contoso implementation, and for Fabricam, we're getting the appropriate Fabricam implementation. Should pretty clearly illustrate to you the power of namespaces and why you would want namespaces. So let's jump back into our slides, and we'll continue on. So now let's jump into classes. We'll talk about classes from the JavaScript perspective, and then we'll talk about classes, the implementation of classes inside of ASP.NET Ajax. So the first thing, I've got a question. What is a class? Class is really just a template. So we're all familiar with classes if we've written, in classic OO languages like VB.NET or C# or the old VB or C++. A class just really stands as a template. But it's an uninstantiated template, so it's this design time entity. And so when you create an instance of an object, the class gives you the template for what that object has. So if you've defined a couple methods and properties in that class, when you create an instance of an object, you get the implementation of those properties and methods. So it's pretty simple. So does JavaScript have classes? The answer is no. JavaScript doesn't have classes. So you may be wondering, how does JavaScript work? Well, it's a different methodology. JavaScript is what's known as a prototype-based system or architecture, and we'll delve into that in this slide. So although JavaScript doesn't have classes, it does have templates. And so we saw earlier, I kind of introduced to you earlier, that the prototype of a constructor acts as a template. So I'll show you the code in just a minute, but just for now you just need to understand that the prototype acts as a template. Every object instance inherits the properties and methods from its prototype. Every object has a prototype, and every object has a prototype property that refers to its prototype. Okay? Pretty simple once you see it. So we'll see it in code in just a second. So here's an example. So I've got this function person that has two arguments, first name and last name. And inside of there, that's where I'm setting those instance level fields. Well, this is called a constructor, or a constructor function. And a constructor function in JavaScript is typically named the same as what you would name your class inside of, say, C#. So I've got this constructor function. Each of these guys here has their own instance. So if I have two implementations of my person constructor, so I have these two objects out there, they're each going to have two sets of these instance fields in this case. Now down here, you'll see I'm actually adding a toString function to my person's prototype. So my person constructor function has a prototype, and you can reference it by that prototype property right here. So person.prototype, and all I'm doing here is adding in this toString method to my person prototype. So now at the end, when I call var myPerson equals new person, so I'm creating an instance of this constructor, and it's named myPerson. Now I've got myPerson inherits the toString method from my prototype, or the prototype acts as the template for my pseudo class, if you will. Okay, we'll see that again in just a little bit of code. So let's jump right into it. So what I want to do now is jump up into and open up prototype constructor, and let's take a look at this guy up front. Let's jump down here and show him first. Okay, so inside of my prototype constructor, you'll see I've created this constructor function named student. Okay, and I've got two fields here that are instance level, and all I'm doing here is in the arguments to my constructor function, I'm just setting these instance fields. Okay, so then whenever I create an instance of this, I then have access to these fields. Next thing I'm going to do is I'm essentially adding a function called stringIze to my prototype of my constructor. And then I'm adding the implementation. In this case, I'm just returning student and then appending the first name and last name fields to that. So it's pretty simple implementation, but what I want you to see here, if I jump down to the code, what I want you to see here is when I create an instance of that, I'm able to call string eyes on my student instance, although that constructor didn't have that string eyes defined with it. It was added through the prototype, or this is where that template exists. Now this makes sense because I told you that these are instance level variables. You wouldn't want to store an instance level function for each instance. You'd be wasting space. So what we want to do, we have another means by which to templatize or attach that function, and that's through the prototype. So that should be relatively clear. So if we run this now, and if I call that method, now I've got that implementation available to me. So all I did was click on show student and alerted student.stringEyes, which should illustrate to you that we inherit from the prototype. Now I want to show you some of the relationships and how everything relates, because it can get a bit confusing. So what I'm doing here again is creating an instance of my student. So I'm calling var student. Let me go to full screen here. So I'm calling var the student equals new student. So I'm creating an instance of my constructor. Now what this line here is doing is showing that the constructor for my object instance is really the constructor function, or my student function, which we saw earlier. So you remember that student constructor. I'm just illustrating that these are the same. So when we alert this, it will show that these two truly match. Or in other words, the constructor of my student instance is equal to the constructor of the prototype of student. So my student has a prototype, and the prototype points back to the constructor. Good? Okay. The last thing I want to show you is that if we take a look at this constructor function, it has a prototype, and that prototype is the prototype of the student. Now again, don't be terrified that I'm going through this too quickly and that this is circular and you may be getting a little bit lost. That's understandable, because if you're not familiar with how JavaScript works, this can be a bit daunting. I'm providing all of this code to you. It'll be out on my site at robbagby.com within the hour. You can download it and start playing with it. And it should be a valuable resource for you to understand the relationships between these objects. But this is important to know because we utilize some of this functionality inside of our Ajax libraries. And so I'll point that out when we get to the Ajax classes. But it's important for you to realize the relationship between the prototype and that constructor. Okay? So one last go through it. You've got this constructor function, and then you've got this prototype down here. The constructor has a pointer over to the prototype, and it's .prototype. So it's a property. The prototype can point back to its constructor, and that's .constructor. Okay, so you can refer to either one from either. So when we show that the student.constructor equals student.prototype.constructor, this guy's just pointing to its prototype, which is pointing back to himself. Okay, so let's go ahead and see how this works and just prove that all of these statements are the case. So true, true, and true. So it's pretty clear that the student's constructor is really just pointing at that student function. The constructor is pointing to its prototype, which points back to the constructor, and that the prototype is the prototype of the student. I would ask that you take this code, download it, and play with it, and it should be relatively illuminating for you. Now, the last thing I want to do is show you some of the different options you have for creating objects inside of JavaScript. So, let's see. Well, that's not the guy I'm looking for. So let me just, okay. I think I have the code inside of my, inside of here. Okay, so what I've got here is just a simple constructor function called dog, which takes in name and breed, and then sets these fields here. What I want to do is show you some of the options you have to create this implementation of this constructor. So if we take a look at this next method called create objects, which one I'm going to call, I'm going to show you 4 different ways by which you can create an object. You can essentially var a variable to new object, which creates that object, or I can use curly braces and say var odog equals open and close curly brace and create an empty object, or I can use the curly braces, I can pass arguments, and so var odog equals, and I'm passing some name value pairs. Name is Towser, breed is Golden Retriever. Or lastly, I can essentially create a new dog, which uses my constructor or my template, and pass it in the arguments defined inside of that constructor function. Now, once I use any one of these, I can start setting some properties. In these cases, I don't need to set any properties. I passed them in, and in this case, I passed it into that dog object. Down here, for these guys, I want to set some properties. So I got a couple possibilities there as well. I can use the brackets operators and set odog1 open bracket name equals Towser or breed Golden Retriever, or I can use the dot operator and dog name odog2.name equals breed equals. And this is important as you start scouting through other folks' code. You'll see differing uses here, and you need to understand what's going on and how this works, because we're able to, here you'll note that we're dynamically adding an implementation at runtime to an object. This object, odog1, has no concept of what it is, and we're adding behavior at runtime. And that's important to note because you can do that in JavaScript. And so all I'm doing here is just alerting out the dog 1 through 4's name and breed, just to show that we're getting 4 paths to the same end. And so if I click on object set and props, odog1, Towser, Golden Retriever, through 4 is Towser and Golden Retriever. Okay? So that just kind of illustrates to you the 4 possibilities for creating these components. So let's jump back to our slides, and that was the JavaScript implementation of, it's not really classes, but how you are able to work with templates, if you will, in JavaScript. So let's take a look at how we do it in ASP.NET Ajax. Well, classes in ASP.NET Ajax extend the functionality of JavaScript, meaning we still create constructor functions and we still create these prototypes. So if you've been creating some classes or following some of the online examples, you've probably seen the constructors and prototypes and maybe didn't know that those were really the JavaScript way of doing it. We still do that, but we do some additional things, which I'll show you in a minute, to allow us to do things like reflection against our classes and to keep from colliding. And so we get some additional functionality with our implementation of classes, including the ability to consume namespaces. We simplify implementation inheritance, which I'll show you a little bit later, classic inheritance. I'll show you the JavaScript way, which you're not going to have to really worry about too much, but it's very good to know. And then I'll show you how we do it in Ajax and how much simpler it is. We give you interface inheritance, so you can create interfaces and then implement those interfaces. And then we've got support for reflection, which is important so that we can figure out what type of object we are, etc. Well, and then I'll show you a brief use of reflection a little bit later. So how do we create these classes in ASP.NET Ajax? It's pretty simple. First thing you do is you call register namespace if applicable. So if you want your class underneath a namespace, you call type.register namespace. We saw that before. The second thing we do is we define the class constructor function. And so you include the namespace in the class name. So when you're creating the constructor function, you use the fully qualified class name. You declare all your private fields in the constructor function. The nomenclature, our use pattern is you prefix private fields with an underscore. They're not really private. You can see them just like you can properties, but we've got this kind of implicit agreement that people, when they're consuming your class, will not depend upon those. And so they should be accessing them via the public property getters and setters. One important thing to note, and I'll call this out a couple times, and I'll show you a demo of the importance of it. You need to call initialize base. That's a must because the infrastructure depends upon initialized base, specifically when you're dealing with inheritance. And I'll show you a demo of that in the inheritance section. But just remember, if you are if you're doing implementation inheritance, you need to call initialized base or it won't work. And I'll show you the initialized base on the next slide. Next, you define the class prototype, just as you normally would. And inside of here, you define the members that you want to support, methods, props, events, etc. And then lastly, you call type.registerClass. And in type.registerClass, as we'll see in later demos, that's where you define your parent object as well as your base object, if you will, as well as any interfaces you want to inherit. Or you don't have to pass anything. You can just call registerClass on your class name. And that's enough for the infrastructure to know that you are a class and that nobody else is going to be able to register themselves with the same class name, preventing any collisions. So let's see what it looks like here in code. The first thing here we've got is, if you remember the 4 numbers we saw earlier, type.register namespace. So we're creating a namespace, contoso.components. Here's our constructor, contoso.components.employee equals function SSN. So in this case, we want to pass in an SSN. Here's our call to initialize base. Now down here, this is where we're setting that field that, for all intents and purposes, we're treating as private. So that's our constructor, just like we saw in JavaScript. Now, third thing is we create our prototype, just like in JavaScript. And inside of here, this is where we add our implementation, just exactly like you do it there. And then 4, the major difference is we call register class. So contoso.components.employee.register_class, pass in the name of the class we're registering, and then in this case I'm implementing sys.component, and I could have passed in any interfaces. I don't need to implement component. I can just pass in contoso.components.employee. But really the big difference between here and JavaScript, we've added the namespace optionally. We don't have to. We called initialize base in our constructor, and then down here we called register class. And this is what's going to give us that additional functionality. So the register class signature looks like this. You've got your class instance variable. You call register class, passing it in, type name, and then optionally base type, and optionally any interface types. It's pretty simple. Again, if you are implementing using implementation inheritance, make sure you call initialize base. Nothing will work if you don't. So let's take a look at this and see how the Ajax classes work. So let me go here and let me close everything but this. And I want to open up a sample that I have called employee implementing person. Okay, so what I've got here is, first thing you see is I called type.register namespace, and my namespace is called callit.components. Now, I'm creating my class, person, and I'm passing in the fully qualified name of my person class. Callit.components.person equals function. In this case, I'm calling initialize base, so I should be implementing something here. And then I'm just adding in my instance level fields. Down here, I'm creating my prototype, again with the fully qualified path, and I'm adding in my implementation, my public getters and setters. Again, the naming conventions are you use get underscore and set underscore. And then I've got a method here called show name, which just has a simple implementation. I'm returning my name and then appending in the name field. Lastly, what I'm doing is calling callit.components.person, so it's my fully qualified path again, register class, callit.components.person again, and telling it that I'm implementing component. You don't really need to worry about what component gives you at this point. We'll talk about that in a later webcast. Actually, I believe Thursday we're going to be talking about implementing, creating controls, and I'll talk about implementing sys.ui.control and sys.component in there as well. But that's really all you really need to see and how it works, creating classes. That's it. It's that simple. Now I'm able to create this class that implements either another component or implement some interfaces as well. And I think we've got a demo here to kind of illustrate that. So show how to create components in ASP.NET Ajax. That's going to call this method right down here to create Ajax classes, and we're going to create an instance of my callit.components.person, and then we're just going to call showName on my person, and then another call to employee, and we're going to call showName on my employee. And incidentally, that employee is a very similar implementation here. As you saw in person, the big difference is that we're implementing our person class that you saw, callit.components.person. Down here in employee, we're actually implementing that class. So in this case, we're passing a little bit of additional information here. We're calling initialize base, which is going to be our person class, and passing it in that data that constructor wants here in this array, and then we're setting some additional data here. And some inside of the prototype here, I've got some additional functionality. So down here in my employee, I'm calling register class, passing it in my person class, and so that's going to be my base for my employee. Okay, and so that's kind of interesting the way that works. So if we make this call, and I click here, you'll see that's the implementation of my person, and that's the implementation of my employee. So you'll note there that I actually got the person's implementation in my employee of showName. We'll go into inheritance in just a minute, but one thing to note: showName exists in the person prototype, but if I scroll down to the employee, there is no showName. So I did get the implementation from my base class. So that's kind of cool. We'll go into that in more detail in a minute. What I really wanted to do there was just show you how simple it is to create this class inside of using the ASP.NET Ajax methodology. And as you'll note, because we're able to namespace these, we saw earlier, then we can prevent varying collisions. And you just saw an instance of where I was able to take advantage of inheritance. But we'll go into inheritance and interfaces in more detail in the upcoming session, in the upcoming slides here. Right now, I'm going to kind of jump through enums really quickly because it's relatively simple. Once you understand classes, you should understand enums pretty easily. Enums are a distinct type that consists of a set of named integer constants. You can express them as hex or int. Essentially, you've got your same namespace. You've got essentially an empty constructor, if you will, and then inside of your prototype, you essentially assign your values. So in this case, I've got DM state, which is desert mountain states. My territory is desert mountain, so Arizona and Colorado are a couple states inside of my territory. And then you just call register enum, and you pass in the fully qualified path to your enum. Let's take a quick look at this in code. So let me go to, let's close everything with this, and I've got some code here called enum. Now this is kind of interesting. I'm going to show you a gotcha in here, something to be aware of if you're messing with enums. Not messing with, but if you're implementing enums in your applications, I want to show you some deeper level stuff, if you will. In this case, I'm calling register namespace. I've got samples.enum. I've got my constructor here and my prototype. And note here, I'm assigning four values here. Arizona, or 6 values. Arizona through New Mexico, or 1 through 6. Also note that New York, NY is not in this list. Okay, just keep that in your pocket for now. Now you'll note here I'm calling register enum, passing in the fully qualified path. My enum is now registered. Now I've got a method down here, a function down here called getTravelDistance that consumes that we're going to pass my enum value to. So I'm going to create an enum value, I'm going to pass it in here, and I'm going to return some information depending upon the enum value I've passed in. So I've got a distance from home variable, and depending on the enum value, if it's Arizona, I live in Arizona, so the distance from home is 0. Colorado is 500. Montana is 1,000 miles from me. Nevada is about 300. Utah 6. New Mexico 300. Now note in this method, I'm consuming a member that doesn't exist in my enum. New York does not exist here. Okay? But if somebody does pass me this, which we'll show you is possible to do in JavaScript, then I'm going to pass back a 3000. Otherwise, if it doesn't exist in the list, I'll pass you back a -1. Now I have another implementation which is exactly the same called getTravelDistanceInt. The only difference is I'm evaluating against the integer value, okay, as opposed to the enum value, which is samples.enum.dmstate.az. Okay. Now, apologize for the scrolling. Get you back down here as quickly as possible. Now I also have implemented that New York, or number 7 here, 3000. So that's it. That's about it for this class, or this demo here. What I want to show you is the consuming code now. So inside of here, let me go to full screen. Inside of here, the first thing I'm going to do is I'm going to call getTravelDistance, passing it in Nevada, which should pass me, I think, 300, Montana, 1000, and then New York. Okay, well, how did I create that? That doesn't exist. That shouldn't work, should it? But it does, because I showed you earlier you can dynamically create objects at runtime. So I'm able to pass this in. You would hope that the infrastructure would realize that this is not valid in our enum and would do something, but that's not the case. Let's take a look at it. So I'm going to show enumerators. New Mexico is 300, Montana is 1,000, and the travel distance to New York is 3,000. Well, that's not good because somebody was just able to work with my enum in a means that I didn't predict earlier. And so that's a problem that that we need to kind of deal with. One thing I can do here is if I take a look at and change this to getTravelDistanceInt and see how that works. Let's go ahead and rerun this. Let's reload this page. We'll refresh it. And then call show enumerators. And you'll see in that case, when I check for the integer value, the travel distance to New York is -1. Well, why was that? Well, that should be relatively clear. Somebody crafted up this object on the fly, but they didn't assign it the value of -1 like it would have been assigned inside of my definition. So it didn't give it that 7 value that I was expecting. So when I checked down here against the integer value, it did effectively save me or act in a means that was more in line with what I would have predicted or hoped. Now, all that being said, if we use this integer, we can also go through and affect ourselves at runtime, in this case by creating this New York and assigning the value here, and then it will work with my getTravelDistanceInt. So if I go ahead and extend my enumerators, I just wanted to show you here that people can do things at runtime that you can't do in traditional languages that you're familiar with, like C# and .NET. You can corrupt up these objects on the fly at runtime and dynamically change your enum. So you just need to be aware that that can occur. That's the only moral of the story. I really wanted to show you how enums work and then show you how how you can get into trouble with some of the dynamic natures of JavaScript. Now I'm going to jump back to the slides. So we still have some more to cover here. We're going to go into inheritance. So the first thing I'm going to do is show you inheritance. We'll talk about it. What is inheritance? It's the ability to derive from another. Does JavaScript support inheritance? You betcha. So is the Ajax implementation the same? So we saw that the Ajax implementation of classes just really extended what we're doing in JavaScript. Is it the same for implementation inheritance? And the answer is no, it's not. And we'll talk about that in a minute. But at first I want to show you how it works inside of JavaScript. So inheritance in JavaScript. Right up here you'll see I've got my base class. So I've got my constructor, my person constructor, and then I've added this getName in my prototype. So I've got this getName function. And then I can add a stringize method in my person prototype as well. So now I've got this person constructor which has 2 methods defined in the prototype. In my implementing class, my employee down here, the first thing I do is I call person.call. And so inside of person.call, this is where it gets a little bit complex and where you'll probably want to watch the recording here and play with this a little bit. What you need to understand is that every function object inside of JavaScript has this call method. And what it allows you to do is to call the function as a method of the first passed in argument. So I can call this person constructor as a method of this, which is my current object, right? And so in this case, what we're really doing is calling this person constructor, passing it this, or so it's running under our context, so it now has access to these variables. Okay? And so I'm able to call this constructor, and that's really kind of the key to how or the first step in implementation inheritance inside of JavaScript. All we're doing here in this next line is just adding some additional implementation. Now down here, if you'll remember when we talked about our prototypes, every constructor object has a prototype. What we're doing for our constructors, we're setting the prototype to be the person prototype. Okay? And so now we're just resetting or pointing this prototype at this person prototype. And then, because this person prototype's constructor is going to be pointing back at the person constructor, we're going to reset our new employee's prototype's constructor to point back at the employee. You don't really need to follow that too much. What you need to know is that it's relatively complex and relatively painful for you to work with. It's probably valuable for you to understand it. So again, you can go through this, go through the code that I provide to you, but you can work with our implementation of inheritance in ASP.NET Ajax without understanding this. We've created a completely different implementation. So let's first jump into show you how JavaScript inheritance works. We'll do this pretty briefly, as it's not the most important thing we're going to show you today, but I've got this file called inheritance.js. So inside of here's our base, and so it's our base constructor function called person. You can pass in first name and last name, and here we set these instance level vars. Now down here, we're adding the getName and the stringize methods that we saw earlier. Remember those? Now, here's my class that's going to extend it. So I've got my employee, and it takes not only in first name and last name, but also employee ID. Then here's that person call that we saw earlier. We're saying essentially called under the context of this, and pass it the first name and last name. And then we're extending, adding an employee ID into the prototype, or into the constructor, excuse me. Now, here's where we set the prototype to be the person's prototype, and then we reset the constructor to be back to our employee, so that circular relationship works for us. Otherwise, it would be pointing back to person and wouldn't work. So this essentially is what you would do to create an employee that implements person. So let's see how that is implemented, or an example of that. So what we're going to do here is just create an implementation or an instance of our employee, passing it in all the information that the constructor wants, and then we'll call e.stringize, keeping in mind that our employee doesn't have a stringize implementation. But when we set this prototype to be the person's prototype, we're now going to inherit that stringize implementation. So let's go back and run this. JavaScript inheritance and stringize works. Now, can you override inside of JavaScript as well? Sure, I can override that by simply going in here, and in this case, I'll just uncomment this code, and now I've got my own implementation of stringize that's going to override the inherited stringize that we inherited from the person prototype. So in this case, we're going to push out employee. We're going to pass this .getName and pass in the additional employee ID. And so let's refresh this, and let's go ahead and call inheritance again here. And so now we got our new or overridden behavior. So you have this concept of inheritance in JavaScript, and it works fine, and people have been working it for years. We just changed the implementation for us for some varying reasons, which we'll discuss in a minute. The one other thing I want to show you here is to talk to you about how JavaScript inheritance is pretty dynamic, because JavaScript is really, you can do a lot at runtime in JavaScript that you're probably not used to doing. What I want to show you here is, in this example, I've created that same employee instance here, instance of that employee constructor. Then what I've done here, after I've created this instance, I've added a method called don't do much to my prototype, which I inherited. You would think that this instance wouldn't have that implementation because I did this afterwards, but it does. So when I call e.don'tDoMuch, you're going to see that I'm still inheriting the implementation of this prototype. It's pretty cool. So let's go ahead and show that. So I got it. I got the implementation of that, even though it was added after I had already inherited. So these pointers are runtime pointers. So it's important to realize if you run into some issues that don't seem to make sense, you need to know that it is possible to do things like this inside of JavaScript. Now I'll show you later that that's not possible or inside of our implementation inside of ASP.NET Ajax inheritance. So what we have in ASP.NET Ajax is single inheritance, so you can inherit from one base. You specify the base class and register class. I've showed you that. I've talked to you about the importance of calling initialize base, and I've mentioned that it's a different implementation than JavaScript. And how we utilize inheritance in ASP.NET Ajax, I just walked through all of this. Specify your base class, call initialize base, add any members, and then override any members that you want to override. Here's how it looks. Specify your base class down here when you call register class. 2, call initialize base. 3, add your members. 4, you can override any members that you want. You can look at this when you get the slides downloaded off either my site or you'll get them in the email. So a little bit deeper how this works. What we really do is we recurse through the inheritance chain, and we start at the top level. And for every type that has a parent type, we actually push the actual member from its base down to the inheriting type. So we're actually moving. Remember I showed you how we can dynamically add members. We're doing just that. We're actually adding each member from your parent, physically adding it down into the child. What that means is that we're not following the same pattern that we did where we essentially inherit from our prototype, and so that some of the dynamic stuff isn't going to work. So let me show you how that goes. Again, all that code is available to you if you just download it. You can take a look and see the exact ASP.NET Ajax implementation. I downloaded it off of ajax.asp.net just like everybody else, and saw exactly how that works. So let me just jump in here and let's take a look at this guy here. You remember, I've shown you this before. Essentially, we've got our register namespace. Here's our fully qualified path for this is our base class person. And then I've got my implementation down here. I've got my prototype for my person with my implementation, my getter and my setter for my instance level field. And then I've got this show name. Here's where I call register class, and in this case I'm just implementing sys.component. And again, a later webcast will talk to you about what's available to you when you inherit from sys.component. Now, my implementing class, pretty simple. Again, using that same namespace, I'm essentially here's my constructor, where I'm extending the name that was passed to my base constructor and adding emp ID. I'm calling initialize base, passing it a reference to myself, as well as name, or the argument I want to pass. Then I'm just setting the instance level vars for my extended fields, or the additional fields that my employee has. Inside of my prototype, I'm just adding some additional, I'm adding an additional getter and setter. Then I call register class, just like I did before, but in this case I'm telling it I'm implementing callit.components.person. And then I call sys.application.notify script loaded to let the script manager know that this script is all fully loaded. It's pretty simple. So let's see what we get for that. So inside of here you can see that I'm going to create my callit.components person, pass in Rob Bagby. I'm going to call person.showname. Down here I'm going to call callit.components.employee, pass it Rob Bagby as well as the additional data, and call employee.showname. Now, if you'll remember, I don't have showname inside of my employee, but I should still get that implementation. So let's see it. Name Rob Bagby, name Rob Bagby. So I inherited that functionality. Pretty simple to do. I can go in and I could have overridden that. So if I copy show name, just for simplicity, and we move this down into my my inheriting class, I can override it, and we'll just say employee name equals this dot name, and save that. And if I refresh this, we'll see that now name Rob Bagby, and I've overridden the behavior. So it shows you just what I really want you to see from that is the simplicity of how we, comparatively from the JavaScript methodology, all we had to do to get that functionality in addition is this right here. That's the only thing we did in order to get that functionality. So the simplicity is there. As it turns out, we get some additional functionality out of it when you start looking at reflection, but maybe we'll save that for a later webcast. So let me jump back up, and I think, well, let's see, did I have one more demo in there? Last thing I want to show you real quick when it comes to this inheritance is to show you how it's maybe not as dynamic as it would be in the JavaScript version. So in this case, you remember when I added that don't do much functionality here in the last example? Let's see how that looks inside of ASP.NET Ajax. So, excuse me for clicking back and forth. But in this case, I'm going to call it.components.person. I'm going to call person.don'tDoMuch. Do the same thing for employee and employee.don'tDoMuch. So I'm adding this don't do much to my person. So we'll see if my person will inherit that and then my employee. See how that goes. Person gets it. Oops. And I think I only alerted it once. Well, what you saw here is my person got that. I'm not quite sure why this one didn't pop here. I might have got a typo in there. What you should have seen is that this will work, but if I change and move these guys above where I dynamically added that, because of the methodology that we're employing where we actually physically add the members from parent base to child, you won't get that same dynamic nature. That would not have worked. Let's move on because we're almost out of time. And I've got just one last section to show you, which is interfaces, which is very simple to work with, so we won't run out of time. So creating interfaces in ASP.NET Ajax is simple. Again, it looks just like creating a class. Register namespace, you define the constructor, you include the namespace in the interface name just like you do in classes, so the fully qualified name. The constructor is empty. You define the interface prototype, so you define the methods, the properties, and the events, but you don't implement anything. And then this is a typo. It should call type.registerInterface. So I'll fix that slide. But you just call type.registerInterface. So inside of here, you namespace, type.registerNamespace shopping, your empty constructor, your prototype with definitions and no implementation. So there's no implementation in that curly braces there. And you call registerInterface. Very simple. Now, let's just see it in code. And let's just take a look at our interfaces. Oops. Interfaces. So here, register namespace shopping. Shopping.I, obviously you still use the same nomenclature, naming conventions, and I. So I create my empty constructor, my prototype, which has my functions defined, but no implementation here. Call registerInterface, passing it in the name. Now, in this case, I can create I'm going to create a FedEx shipping with an empty constructor here. And I'm going to call FedEx shipping.prototype, and I'm going to go ahead and create an implementation of my calculate shipping that I defined in my interface. And then I'm going to call register class at the bottom here, and then pass it my interface. So did you see what I did there? I created, this could have still had information inside. This is my class that implements the interface. I could have had additional arguments and instance level fields in this function, but I just chose not to in this case. But I actually implement that member of my interface, and I give it an implementation. So in this case, it's calculate shipping. In this case, I just check for the distance that you pass in, and if it's less than 500, I charge you $9. If it's less than 1,000, I charge you 14, and otherwise I return 99.99. And the real net is just in the register class, you essentially pass the interface that you want to implement. I've got another class in here called BAGD Express Shipping, which also inherits or implements that interface, but I have a differing implementation. It's 99, 114, and 199. So I'll show you how to tie this all together in 1 minute. And the last thing is under shopping.noncompliant express doesn't implement the interface. So it's got the same method, but you'll notice in the register class, I'm not passing in that interface that I'm implementing. Okay. Now, last thing, I've got a method called calc shipping. Calc shipping takes an object and then the distance. And the first thing it does is it uses the reflective capabilities in ASP.NET Ajax to make sure that you implement that interface. If not, it throws an error. If so, it calls calc shipping. What I really did here is just kind of show you an example of how you might implement like a strategy pattern using interfaces inside of ASP.NET Ajax because you have that capability now. So in this case, what we're going to do is under test interfaces, I'm going to create my FedEx shopping. I'm going to call calc shipping. I'm going to create my BAGD Express shipping. I'm going to call calc shipping, passing it BAGD Express. And then I'm going to create my non-compliant, and I'm going to call calc shipping, passing it that. And we're going to alert all these, and in this case, if an error occurs, I'll alert that out to the screen. So let's see how that looks. There's my my FedEx. There's my BAGD Express, and there's my error that occurred because I'm not implementing the appropriate interface within my strategy pattern. So that's a kind of a brief use of interfaces and how-to on interfaces inside of ASP.NET Ajax. Again, if you have questions and answers, you can submit them using the Ask button. I'll be staying on until they pretty much run out. Otherwise, you can send me email, rob.bagby@microsoft.com, or you can go out to my blog and at robbagby.com and download the slides and the sample code. I'll put those out there within the next hour. So let me go ahead and open up Question Manager. There's a ton of questions here. Tracy, do I have time to answer some of these questions on the phone?
You bet. That would be fine. I'll go ahead and just remind everybody to submit your questions in the Q&A panel found at the bottom of their screen. I'll go ahead and post the survey for today's session, and I do want to remind everybody that filling out that survey today will automatically enter you in to win this Microsoft Zune. So it gives you a little incentive. And here's the survey. Rob, go ahead and feel free to answer some questions.
Okay. I got a question from Dennis L. Is it possible to create multiple constructors for your prototype? And the answer is no. You could have multiple constructor functions and then just keep changing dynamically which constructor your prototype is pointing at, but you can't. It's a one-to-one relationship. So I'm going to just put no. What's the difference between the open and close bracket and dot operators when setting properties? There is no difference. Will the code be available? Yes. My blog site is robbagby.com, and I'll put the code out there within the hour. And let me post that out there. Which classes are recommended in ASP.NET Ajax to implement card space? There are no classes in ASP.NET Ajax now to implement card space. If you're working on card space, this is probably a topic for another presentation. This is probably not the appropriate venue for this. You can, Stephen, you can go ahead and send me an email to rob.bagby@microsoft.com. And I can go ahead and talk to you about how to implement card space and then what you may want to do and how Ajax may or may not tie in with you. Can you explain the benefit of using structured language of JavaScript versus .NET object-oriented? I'm not sure that I would define .NET as non-structured, but JavaScript versus .NET object-oriented, prototype versus the typical class-based system, prototype is dynamic, and that's that's good and bad. I showed you the bad and I showed you the good. So there's good and bad with both. With the advent of the dynamic language runtime, certainly I'm not going to make a value judgment saying dynamic bad or .NET or class-oriented bad or good or either. They both have their own feature sets, and so there's no good or no bad. It's depending on your preference and what you want to do. They both have advantages. And so let me just post that, and then let's see. What is prototype? Why do we use prototype? Prototype is an architecture. And so JavaScript is a prototype-based language, meaning it uses the prototype object as the template for your class. And so why we use that is how JavaScript is set up. Okay, so let's go to the next one. Does the JavaScript implementation work on other non-IE browsers? I assume you mean the Ajax implementation. Does that work on other non-IE browsers? And the answer is yes. We actually have some great examples of using our Ajax libraries inside of PHP. Excuse me, that's platform, but I can actually run that exact site we had inside of Firefox or any of the other browsers. So yeah, we're compliant across the board. In fact, there's inside of our Ajax client libraries, there's actually a layer in there for browser compatibility. So yes. What is the open and close bracket for when passing name to initialize base? That's the means by which we can pass an array. So we're able to pass an array. The question was when I called initialize base and I passed open bracket and then whatever I passed close bracket to initialize base, I was passing an array over to my base class's constructor function. So that's how I pass multiple arguments. Thanks for a great webcast. You're welcome. And let's see, awesome presentation. Look forward to others. Keep it up. Well, thank you very much. And let's see, can you please explain the architecture behind register class and initialize base? What exactly happens behind the scenes? Okay, so this is a relatively long one. Let's see, how can I do this in the shortest period of time? I actually have some pseudocode for register class. And if you email me your question, so just send me an email to rob.bagby@microsoft.com. I'll send you off the pseudocode and where to find it actually in the code. And so that's probably the best means by which we can accomplish this, because quite a lot goes on. Inside of register class, we actually go through and do some checking up front. I guess I'm going to answer it anyways. We actually go through and do some checking up front to make sure that the caller is of the same type as the type that you're trying to register. So you can really only register the type of yourself. We go through and make sure that if you are passing in a parent, a base object, that is actually a type. We go through all of the interfaces and do some same type checking on the interfaces. We then register. We set some supposedly internal properties on your object, storing that you are indeed a class. We store inside of a global collection, if you will, the name of your class, and then initialize base essentially is going to do a number of things, including call the method that goes through and actually pushes all of the base objects implementations down into your object. So it's pretty complex. If you send me an email, I'll send you off some pseudocode, and then you can then also show you where it exists inside of the code. Is there a good IDE that allows for IntelliSense of JavaScript? You're going to have to wait for Orcus. You can download Orcus right now, so download Orcus. And that is our next version of .NET, and it's .NET right now, codenamed Orcus. I think it's 3.5, codenamed Orcus. I would suggest once that comes out RTM, you're going to have great support for JavaScript, IntelliSense, etc. So, I would say download now the CTP bits, and you can play with that. And then when it comes production, you're good to go. Okay, you're welcome. Sorry, I'm talking to myself, trying to answer some questions. And let's see, can you implement static classes with the framework? You can essentially create static methods and make those static calls by essentially pushing things into your constructor. And so yes, in a means, yes. And let's see. Hello, thank you for your session. I know I need to go through your code because I had problems with my connection. The country Lebanon is not listed in the list of countries. My apologies for that, Bilal. My code is available for you. Appreciate you. I know it's late for you there in Lebanon, so thanks for staying up late. And again, shoot me any questions if you have them. Let's see. Thank you. Is there any good MS Ajax training resources? There are classes. I know Pluralsight does some MS Ajax. I'm not sure that they are doing the client-side libraries yet. You're going to have to look out there. I'm not sure. Right now, Dino Esposito's book is going to be coming out. Dino works for a training company or owns one, and I'm sure they've got some. So I'm not sure though. So I don't know. So sorry about that. Are your webcasts stored on the MS website? They are stored on the MS website. And also, if you go out to robbagby.com, you will find a listing of my webcasts. And so I put them out there normally a couple days afterwards, the links out to the webcast, because I'll get back the recording just like you guys do, the address to the recording. This webcast is one in the series you are doing. I need to catch up. One is the next one. My next webcast is Thursday. And also, if you go out to robbagby.com, I actually have a post out there that tells you when my upcoming webcasts are. So just look for that posting, and it'll show you when all those webcasts are. Let's see. I think I only have one question left, which is Tom K. And it says, is the namespace concept similar to J2SE's package concept? And Tom, I'm not sure. I'm not familiar with the J2SE's package concept. But if you send me an email, I can talk to somebody that may know that answer. Really, all the namespace does inside of our world is it creates an object hierarchy that when you then go to create your class with that namespace in it, your class gets created underneath that object hierarchy. And so if you remember when we created those classes, when I dynamically added differing methods or fields to objects at runtime, you can create child objects at runtime as well, and that's what namespaces do. So that's it. And then somebody just sent me a nicety, and I really appreciate it. Let's see, how do you find private members or methods? That's a loaded question. Private members or methods, although are difficult to do in JavaScript, you can do using the concept of closures. However, they're relatively painful to do. And if you want to know how to do that, send me an email and I can send you out some links. To make them truly private, you can make them truly private using closures. And but I probably can't explain it over the phone, so I'll send you some links out there. So send me an email to rob.bagby@microsoft.com, and I will send you out some links that will talk to you how to do that. And Tracy, that's it for the. Whoop, as I just said that. Oh, somebody, that was a nicety. I appreciate that. And Tracy, that's it for the questions. And
All right.
I'll hand it back over to you.
Excellent. Well, I do want to extend a very special thank you to you, Rob, for your presentation and answering all the great questions we had come through the queue today. I also want to thank the audience for attending today's Msdn webcast. Ladies and gentlemen, this will conclude today's session. The audience may now disconnect from the audio portion of today's presentation.